I'm the director of the Bristol Centre for Supercomputing, which we established here in Bristol to build this Isambard-AI supercomputer, which you may have heard of. We've been in the news quite a lot over the last couple of years. And of all the AI stuff that's been announced in the last week and in the last year or so, the first big thing that's actually really happened is Isambard-AI, and it's right here in Bristol. So I'm going to tell you about what we're doing. So if we go on to the next slide, you should be able to just hit space, I think, and it should do it. Or click the trackpad or something. There we go. So what we've done a lot actually. While I've been around a lot, we've been very, very focused, doing lots of different things in a very short space of time. So we've grown a team from nothing to about 25 people over the last year or so. We're at the University of Bristol, in case that wasn't obvious, and we're delivering huge amounts of really exciting new HPC systems and services for the UK. It'll be over £300 million worth, all here in Bristol, and it's actually now all in. It's all in and up and running, and it's all in production. We are hiring as well. I thought I'd drop that in, and we'll kind of like be constantly expanding if you're interested in what I'm about to tell you about. So on the next slide. We've actually built 3 supercomputers and 2 data centers in the last 18 months or so. If you've been involved in any of those sorts of things, you'll know that's actually quite hard. It is really hard. It's mostly hard work. So we've got a brilliant team of people. And we thought really long and hard about how to do these things quickly. The government basically gave us a challenge. Could we build a big AI supercomputer as fast as possible? Because in the UK, we just didn't have anything like that. So if there was a trade war, for example, and somebody said you can't have access to something like ChatGPT anymore, could we train something like that from scratch in the UK? And the answer was at the time, no, we couldn't. We'd be screwed, basically. We just couldn't do anything like that. So the government said, could someone build a big AI supercomputer and do it fast? We'd just been building a smaller system which we'd used a modular data center approach for. So these are containerized shipping containers. Your data center is basically something that looks like a shipping container. It's a big prefabricated metal box with all of the stuff inside that you need for plumbing and electrics and monitoring. And we'd just done a smaller one of those. So we knew we could do that sort of thing. And while we were building that, and that was Isambard-AI, we'd found a location that the university already had where we had space and power. It had 5 megawatts. So we said to the government, well, we could do a modular data center up to 5 megawatts as quickly as you like. And they said, yes, do that. How much will it cost? Which was a fantastic, these sorts of things don't happen very often in your life. They basically said if money was no object, how much, what could you do? And it was basically the whole thing, use all 5 megawatts, which is what we've done. And the system was £211 million. And the sites cost about £17 million to build. And it's all in, it's all in and up and running. So we built 3 supercomputers in a very short space of time. Isambard-AI is actually an NVIDIA CPU machine. So we're all used to NVIDIA GPUs, but it's an NVIDIA CPU machine. It's based on their Grace ARM-based CPU. So that's one of the first of its type in the world. So we built that one. And then we've got our big Isambard-AI machine, which is an NVIDIA GPU AI machine. And we delivered that in 2 pieces, a smaller piece, which we did early on, so that we could get users going and we could get the software stack ready. And then the big main system, which has just gone into production a few weeks ago. And that's about 5,500 GPUs. So that's the really big beast that you could train a ChatGPT or something like that on. It's all from HPE. It uses their network called Slingshot, which a lot of the design was actually done here in Bristol. That's just a coincidence. It's not we didn't buy it because it was partly developed here, but it's nice to have that connection. And it's mostly direct liquid cooled, which we'll come back to that. That's quite important in a minute. So on the next slide, Isambard-AI Phase 2, that's the main excitement. That's the big thing that we've now got up and running. Nearly 5,300 NVIDIA Grace hoppers. That's 21 exaflops of 8-bit. I never thought I'd be doing anything with floating point that's quite that smaller precision. but 4 bits coming as well. So that's a lot of computing power. 216 petaflops, 64-bit for those of you from the traditional HPC background, like myself. So we actually ranked at number 11 on the top 500 back in June. That's the highest the UK's been, equal highest the UK's been for 23 years. So the UK really has not been anything like this high for decades, multiple decades. And now we're really catching up. So it's a really big step forward for the UK. So all that's very exciting, but really it's how quickly we've done it. We dug the first hole in the ground for the big system on June the 3rd last year. And we built the whole site. We built the site, the modular data center, and the supercomputer, and deployed it and accepted it and have gone into production in not much over 12 months, which is ridiculous, quite frankly. These things normally take 3 or 4 years, at least, something of this sort of size and complexity. But we spent time figuring out how to do it fast, and we've used lots of techniques. We prefabricated as much as possible, did many things all at the same time, which normally you do one after the other. And we've managed to bring that time down to just over 12 months, which has been a real achievement. On the next slide. So it's all very well to hear we've done it fast, but it really helps to see it. So we're going to show you a time lapse. So this is the bit of land. This was a university car park. So if you hit the button, it should play, hopefully. The time is at the bottom, so you can actually watch it going on. So we started on 3rd of June last year. Modular data center, we basically build, I'm going to make this much more trivial than it really is. You build a big concrete pad, you put in the utilities, power, water, network, etc. And then at the same time, so while this is going on, our computers actually being built and tested in the factory in the Czech Republic. The modular data center is being built and factory tested in the Netherlands. And then things arrive very quickly. The modular data turned up in the week of November when it was snowing. Do you remember the snow? Actually cost us half a day because the crane drivers couldn't see because of the blizzard. So we had to wait until the afternoon so they could see what they were doing. But the modular data center was actually put in place in 48 hours. We went from no data center to a 5 megawatt data center in 48 hours. It's all been built elsewhere and just assembled on site. So basically all we're doing on site is integrating things that have already been built and tested somewhere else. And that's how you go fast. So this is sort of when it was almost finished. I think the next picture might show sort of the finished. Oh no, that was just before it's finished. That's when the computer was actually turning up. So this is when the main Isambard system was being delivered. That's one of the pallets of equipment on the loading dock there that's come out of that truck. It's all going in. Each one of those big wooden pallets was 4 metric tons. We had one cabinet, 4 metric tons, and that had 440 GPUs in it. It was about £15 million worth of equipment in each one of those wooden boxes. It was all going in. And people were just pushing them around on trolleys. So you sort of think 4 tons, and it's just guys wheeling it around. I think it'd be special equipment for doing that, but big burly blokes wheeling all this stuff around. And we've got, if you click once more, it just highlights down the bottom this sort of mysterious building. It's just a big warehouse where at one end is all our transformers, have these big 5 megawatts of transformers. Comes in at high voltage, comes out at medium voltage. And then another area for our water treatment. So most of the liquid cooling is a closed loop, like your central heating at home. So it doesn't actually use up any water, it just circulates water, goes out to our cooling, which is up at the top right there. Those are basically giant radiators. They're just giant radiators with fans. The fans suck air in through the radiators and blow it out the top. And most of the time, that's all that's needed. There's no compressors or anything in that. They're not chillers. They're just ambient air. When it gets warm enough, they trickle water down the radiator, so they do some evaporative cooling as well. But each of those big radiators up on the top right, each one of those does 2 megawatts of cooling, but they only use 19 kilowatts to run. So these things are incredibly, incredibly efficient. The power usage effectiveness, the PUE of the whole site, is on average under 1.1. So in other words, there's hardly any power gets used to distribute the power and cool the system. It's all so energy efficient. That's largely thanks to the direct liquid cooling of most of the technology in there. We've also got the ability to reuse the waste heat. So we capture most of the heat out of the system as basically hot water. It comes out at sort of 42, 44 degrees. and it's possible to use that for heating. Now we don't do that yet, but we put the plumbing in to do it. And what we want to do, now we've got a bit more time to think about it. We've had to be very focused to make this happen fast enough. Now we've got a bit more time. We're hoping to do a pilot study basically to heat our own building next door, the National Composite Centre, which is a university building, heat that with Isambard. We've never done anything like that before. So we'll learn from that experience. And then the plan is whatever we do next, because I've always got another idea. My brain can't stop, so I'm always thinking about, well, how do we take what we've learned now and do the next one? The next one, we build all that in from the start. And we're talking with the local council, which is actually South Gloss up in the north of Bristol, about how we would maybe use sort of tens of megawatts of hot water to heat local homes and businesses. So that's what it looked like a few months ago. And if you click again...
5 megawatts for all 3 phases?
Yeah, we actually designed just for the Isambard-AI phase 2, we designed for up to 5 megawatts. As it's turned out, and we knew that should be like an over allocation. So we've gone through full integrated system testing when you run everything flat out. We couldn't make the main system use more than, I think it was 3.6 megawatts in the end. And then maximum, if all the cooling was running, it would use about half a megawatt, something like that. So this is a bit more of a sort of promo video for the sort of TikTok generation. So if it jumps around a bit, that's because we're all probably a bit too old for this. It's really aimed at like 20-year-olds. But it shows the modular data center being craned into position. See a little bit more about, I was there when this was happening, and I tell you, your heart is in your mouth when someone is craning millions of pounds worth of your equipment, and it can't go wrong. We can't afford any delays. If they dropped it or bashed it, it would have set us back months and months. And it all went through sort of absolutely faultlessly. Some of the equipment turned up quite early so that we could start setting it up. The rest of it was turning up in March. It was all getting powered on in sort of May and June. Those are the big 4-ton boxes. There were the guys pushing it around. The pipes really are liquid cooling. If you've not seen one of these, the blue pipes are the cool water coming in. Comes in about 27 degrees, comes out at about 42 to 44. So the outside, those big radiators don't have to work too hard. They don't need to make it really cold, just need to make it cooler. That's all going in. The systems all went in about 2 days. Now you go to give a slightly different angle of what it was like all going in. So if you click again for me. And then we had Peter Kyle, who was the science minister, came to do the official switch on for us back in July the 17th. He's now the business secretary, so he's not science minister anymore. Then I've got a new one, Liz Kendall, who will have to sort of train up in what's going on. The red button isn't attached to anything. And I think they never are. But you have something that kind of have a bit of excitement around. It did trigger like a video and stuff, but you don't ever want to risk doing anything really important right in front of somebody important, right? So the system was already up and running, but we did like a pretend switch on when you click the button. But that's when we started allowing users on the system, was back in July on the main system. And this is kind of what it looks like now. So the builders have almost finished and gone. The site's basically all done. So that's been a fantastic achievement by the whole team. And all of this comes down to people. If you say, how have you done this? We assembled a really brilliant team of people, and that's right across our building contractors. That's Oakland Construction, by the way. I can't recommend them highly enough. They've been brilliant. HP's been great, NVIDIA's been great. Everyone else we've worked with, we've found a really good team of people. The people we've hired have been absolutely brilliant. But it all comes down to the people. If we'd not had the right team, this would not have happened in the time that we've done it. And we are starting to run tours. So if people want to come and have a look sometime, you can get in touch, and at the moment we're running 2 or 3 tours a week. So we can take you around and show you what it all looks like. Okay, next slide. Because we are at a university, we're actually sharing how we're doing this. So we're not a commercial company. We're not trying to keep this secret. So our first paper was actually last summer. There's another one out now about our cybersecurity architecture. So if you go just search for Isambard-AI papers on Archive, which is where we publish stuff sort of openly, you'll see what we're doing, and we're going to keep doing that. So we're sharing what we're doing, how we're doing it, why we've done it that way. And for us, it would be a success if other people did the same thing or learn from what we've done and do even better things. So this is not secret. We're not a cloud company trying to keep this secret. We're funded by taxpayers' money, all of our money, and we want everyone to get the maximum benefit from that. Okay, another click. Here's the idea is you sort of go from, many of our users will have been running AI maybe just on their own laptops or maybe in the cloud. If you had a really high-end laptop, and this is sort of gaming class, high-spec laptop, and you were running AI on that today, going from there to Isambard-AI is a massive step up. And we've got projects that have already been running that are doing things now that just have not been possible before, and they're all running around really excited, which is what it's all about. It's what the whole thing is for. So on the next slide, we're going to show you some of the early outputs. So we've already got people producing things quite quickly. So if we go again, one of the first projects that's been running is actually from some colleagues here at Bristol University. And you've probably heard people using AI for looking at images of things like moles and trying to work out, are they skin cancer or are they not? Are they nothing to worry about? This is something that AI has been really good at, apparently. So really accurate, at least as accurate as humans. And there is a bit of a backlog for this sort of thing in the NHS. So it's actually really nice to be able to automate some of that so that you can get through people more quickly. There's been a belief that these systems work better for people with pale skin than darker skin. And these guys ran a project that actually have proven that is true. So that was interesting. And they've got to the bottom of some of why that's the case. And it was largely because they were mostly trained on images of pale skin. So they've retrained these AIs on more diverse images, a wider range of different skin color, and they've got a lot better already. So that's great. So this means there are some people with darker color skin who would have been missed by these systems, and they might have got skin cancer, and now they won't, right? So these are the very practical outputs for some of these things already. Interestingly, they found this hasn't solved all of the problem. So they still work a bit better for paler skin than darker skin. So they think there's something more fundamental about the way the algorithms work, and now they're looking at that, see if they can fix that as well. But it's got a lot better, but it hasn't brought it up to parity. So this is one that's already been running in Bristol. The next one is a very cool one run by a team at UCL in London, and they're trying to do basically the British version of ChatGPT, and it's based on an NVIDIA, a large language model, and they're training it on UK data, so it's being traced on British languages, so Welsh. I actually went to Cardiff University. I've got some friends for whom Welsh is their first language, so I'm actually very interested in this. But also Scots Gaelic, Cornish. So we forget we've actually got multiple languages in the UK because many of them maybe are not something we hear every day. But they're training on those languages. ChatGPT and Llama, it's aware of those things, but they don't try very hard because they're really concerned at a global level. So they might care more about Mandarin and various sort of Indian dialects rather than Cornish and Welsh and things like that. So these guys are doing that. They're also training on UK legal case law. So ChatGPT is trained on US case law, doesn't really know much about English laws, but this one does. And they're doing other things. Their early results are brilliant. They can show they're at least as accurate or more accurate than the latest ChatGPT and Llamas on all the things that they care about. They needed a big enough computer to do it. They couldn't do it before, and now they can. These guys are using a huge chunk of Isambard-AI right now. I think nearly half the machine. They're trying to use it as quickly as they can before the system gets really busy, fills up with lots of other things. So these guys are going great guns. There's a good NVIDIA blog as well there. On the next slide, we've also got a team at Manchester University, and they're using AI to do pollution predictions. And in the same way that you have people doing weather prediction or climate prediction, these guys are doing pollution prediction with AI, with deep learning techniques. They're already making great progress. They've got some early results. Last Thursday, the CEO of NVIDIA was in town in London, and he showed a really cool video which includes some of these guys' results, a nice sort of visual map of estimation of pollution over the UK. And that was all running on Isambard. So these guys are making good progress as well. Next one. So, and there's lots of other things happening as well. We've only been officially open on the full system for a few weeks, but it's filling up quickly. It's mostly for research, so it's mostly for academics, but it's funded by the government, by DCIT, and they are very keen to support startups and SMEs. So there'll be a good fraction of the machine that will be used for companies, and we've already got lots of companies on and running. So if you're possibly interested, we'll have the website at the end. We generally keep links to all of the calls that the government's running. They're very quick to do. They've designed them to be quick and easy, a very short form to apply for time. And we can get people on very, very quickly, like within days. So if you're interested, look at the website at the end and then check us out. We'll get in touch and we'll point you in the right direction as well. So anyway, like I say, I can never stop thinking about what happens next. So this is looking down on top of our site. So this is the National Composite Centre. It's in Emerson's Green, up near the M4 motorway, so in the north of Bristol. And the first, what we call Isambard Park 1, so this is those 3 different systems. It's all down here in the car park. So this is one of the positive things out of COVID was people are working from home a lot more. So the car park was a lot less used. So, that's a good resource. So we got space, which is unused car park spaces, power, and everything else we needed was a bit more secondary. So space and power were the main things. Oh, and we could get planning permission quickly. The university's got 200 different locations across the city, from South Gloucestershire to Bristol City Council to Somerset. And South Gloss has an 8-week planning permission turnaround. The city centre's more like 6 to 9 months, and you might not get it. And Somerset was 3 or 4 months, something like that. So again, we picked the place where we could go fast, which was up in the north of Bristol. Being in a science park helps because it's meant for this sort of thing. So we're down there. That's about half an acre we've used. And if you click once more, you may have noticed this field next door. Well, I've got my eye on that. It's within the science park. That's 4 acres, so it's 8 times the space. It's already got 10 megawatts there. So we've got 5 megawatts today. We could already got twice the power. And the National Grid has recently confirmed they can get us 50 megawatts by 2030. So that's 10 times the power. So we have proposals in with the government to basically do a big Isambard Park 2 next door, 10 times the power, 8 times the space. So if you
might not need more space. The next racks are going to be a megawatt per rack.
No, these computers are very dense. And in fact, even the racks in the current Isambard-AI are a third of a megawatt each, so 330 kilowatts, and that's going up and up. Interestingly, the plant that you need to run all of that doesn't really shrink. So we actually need more space for the coolers and more space for the transformers than we need for the computer. In the past, when the computers were air-cooled, they'd be the size of a football field, and now they're in a room smaller than this. So we actually end up still needing the space for everything else and not the computer. Anyway, so the main thing to take away from this is it's not only possible to do these, this is a world-class system, so it's great that we can do that, and we can do it here in the UK, right? So you often think, it's only other places that can do this. We were running some tours last week and we had people saying, how did you learn how to do this? Where did you go? So no, you don't understand it. No one's done this, right? We are the first place in the world to do this sort of thing, anything like this fast. We've now got everyone coming here to see how we've done it, right? So we can do this in the UK. We seem to think it's only everyone else that can do it, but we can do this really cool stuff. The approach we've used is sort of modular data center. We started off, our first one was sort of under a megawatt. Now we've done 5 megawatts. We've now got plans for a 10 to 50 megawatt campus of this sort of thing. It's a very flexible approach. We wouldn't need to build one big system. We could build lots of smaller ones. Some of those could be for our partners. So if you're thinking, I'd really like a 1 megawatt data center or a 10 megawatt data center, once Isambard Park exists, we could do that for you in 6 months. Once the pad exists and the security is in and the power is all there, 6 months will get you in and up and running, right? So that's what we're aiming at. We can be really, really agile, really flexible. An AI supercomputer, actually the hardware we didn't really do anything too weird with the hardware. It's basically a big supercomputer. All the storage is flash. That was one of the things that's made a difference. That's slightly different for a supercomputer. But most of it's about the software. The software stack is the thing really that makes this an AI optimized system. And I could have done the whole talk just about AI software. So maybe you'll come back again and talk about that in the future. And it's all about people and it's all about skills. And Rich, who's here, who's another person with a brick shirt on, he's leading a lot of the charge for us in terms of training and things like that, and we'll be doing more and more of that in the future. AI skills for all of us, basically. That's most of what I've got to say. I think I've got one more thing to show. So that's the website, basically bristol.ac.uk/supercomputing. You find our website, and we keep links to all the calls that are running from the government, so you can go and apply. If you applied tomorrow, you could be on next week, right? So I really encourage it. It's very easy. The forms are very simple. I encourage you, please, if you're interested, do this and give it a try. It's here, funded by all of us for the benefit of the UK. So go and give it a try. Put it to good use. And then the last thing is another little video, but it does have some sound. But I could very quietly hear the sound on the first one. So this is a promo video from the launch day. So when we had Peter Carl coming, and it just sort of shows a bit more what it's all. There's some funky music. You're not missing much. But that's what the actual system looks like. And I didn't come up with that phrase, but I really liked it because that is the truth. It's built for breakthroughs, but it's powered by people. Without people, all this would be cool, but not really make any difference. So it's all the people that make the difference. So that's everything I had to say. I don't need to rush off, so I'm happy to stand around and chat with anyone. But yeah, we can do really cool, cutting-edge, leading stuff in the UK, and I encourage everyone to do the same. Give it a try. Thank you very much. So did you want to take questions? I'm happy to try and answer any.
What are you seeing about user profile, as in scale of number of GPUs being used, and also the users? Are you thinking this, obviously with anonymous and no names, some people need to step up and get with it, and they will in time, or do you think we've got a gap in the UK that needs to be focused on?
Great question about users. So the system's filling up really fast. Some of the users, so the UK LLM, the people who are training a large language model, they're using about half the system just for themselves. And it's taken them a couple of weeks. They've never had access to anything like this size, so they've had to learn. They've had help from NVIDIA, but they're now really productively using half this multi-100 million pound supercomputer just for one project. Right? Now we're also seeing lots of other projects that are maybe one node, a few nodes, maybe a dozen nodes. And I think there'll be a lot of stuff that will only ever be that sort of size, and it won't need to be any bigger, but there's a lot of it. So there might be 1,000 users who want a couple of nodes each, and they were struggling to find that anywhere else. Where we definitely have dozens of projects that want dozens or hundreds of nodes. We've got 4 GPUs per node, so that's a lot. That's hundreds and hundreds of GPUs. So even at the very beginning, we're seeing a lot of demand. I think within the government, there's a group called the Sovereign AI group, and they ran a call just for a week or two before we opened up. So almost no time. And they had 300 applications that would have used between them would have used the whole machine for a whole year. And that was with like no notice.
Good.
So there's a lot of demand. So the government's really actively rushing to how do we add more and bigger and better. And the signs are, there's a lot of demand, pent up, waiting. There's certainly a lot of people who need training and support to really get going as well. But there was a lot that could just run with it right from the get-go.
So Simon, within that group, that's a good data set. Do you do you see a trend, whether it's LLMs or image recognition or recommendation engines? Do you infer anything?
So, I think the trends are it'll be very diverse. So there won't be just one thing that fills the whole machine up. And we're already seeing that it's all very, very diverse. Some of it's training, some of it's inference, some of it's running simulations to generate data to train LLMs on in the future. So it's anything and everything. The one overarching trend is 80% of all the applications that have run so far have been somehow related to health, which is really interesting. I think we expected a high rate of health-related AI things, but it's been even higher than we were expecting. And even within that, it's very diverse. So some of it's, there's the skin cancer one. We've got people doing, developing vaccines for dementia. Very, very broad range. So it's hard to kind of subcategory. Almost everything would be in a category of one, but lots and lots of it is health related. Yeah.
And do you see a division between training and inference?
Yes, but not any. It's too early to see any long-term trends, and I kind of expect that to change over time as well. So we needed to design a system that was going to be very flexible and very agile, because no one can really predict what people actually want to do. So the system we've got is actually very general purpose from that point of view, and fortunately that's turning out to be the good call. We're seeing people wanting to run all sorts of things that you couldn't have guessed.
Thanks. So the current call, just on the data generation piece, the current calls which are out basically exclude data generation.
Exclude?
Data generation. You can't actually apply for time on the machine to generate data to train AI. That's actually working as calls.
Okay.
Which is really frustrating because it's...
Yeah, we're aware of projects that are actually doing that.
I know some who are, but the actual
but maybe it'd be good to, Rich, we should meet Jamil later. Dan's been waiting very patiently. On Dan.
Simon, you talk about power consumption.
Yeah.
25 years ago, I worked at the University of Manchester. We had a Creighton 3 and there was a statistic we didn't admit too much, is that machine used 10% of the whole university's electricity budget. Do you have a feel about what portion of the university's electricity is going into the Isambard?
Yes, so we're about half the whole university's electricity, or if you like, we just doubled the university's electricity use. I was surprised the university used as much as that. So actually, so about 5 megawatts for the whole campus. So that's, I can't remember, order 10,000 staff, 30,000 students, or a supercomputer. Right. But there are interesting economics. So we are now a bigger customer of our electricity provider, and we get better pricing as a result. So the university's own power bill actually goes down a bit because of Isambard. And we didn't know about that when we were doing any of this. This is all things that come out later. We've also, those of you who are based around Bristol, you may have heard of Bristol Energy Network, and there's a few other really cool energy schemes that go on. People build really big wind turbines, and the income from those actually then supports the local community and pays for energy efficiency improvements for the local community. That group's actually approached us and said they want to build some wind turbines near us, sell us the power, so we'd have local renewable, megawatts of local renewable, and use that to support the local community in that area. So if we were small, that wouldn't work out economically, but because we actually need a lot of power, there are other things you enable. The same with district heating. In Scandinavia, this is very common, and in fact, I think it's by law, if you're running data centers, you have to capture the waste heat in Scandinavia and contribute it to local district heating. So that's like the stick, if you like. But the carrot is, and you get paid for it. So you get paid for your waste energy that otherwise you would have just vented. So this is known technology. This is a solved problem in other parts of the world. We don't do that much yet in the UK, but we are moving in that direction. But you need slightly longer term horizons to really pull that off. We need to be able to promise we're going to keep doing this not just for 5 years. We get funded for 5 years at a time. So Isambard will now run for at least 5 years, probably 6 or 7. But really you need to say we're going to do this for at least 15 years for it to be worth plumbing into a district heating circuit or something like that. And that's, you need the government to be making those sorts of promises. And governments find it very difficult, our governments find it very difficult to make promises that will last across a term of parliament, because the next government might change their mind, right? And we don't like that idea anymore, so cancel it. But, so we're seeing if we can make that sort of thing work out as well. Yeah.
So obviously this is an NVIDIA-based system, and judging by the recent announcements with Jensen, it sounds like the next ones are going to be NVIDIA-based. Have you considered AMD solutions or other hardware architectures, and what's your opinion on where that's going?
Yeah, absolutely. So right now, when we were buying Isambard-AI, we evaluated all technologies, and the best solution we were offered was an NVIDIA one. It could have been something else, but NVIDIA is the market leader, and they've got fantastic software. Many of our users will have already been mostly using NVIDIA hardware, so this for them it's very easy. They can take a container they were running somewhere else, and it just works out of the box. We get people running very quickly. For the next one, we will evaluate all technologies again. It's not definitely going to be NVIDIA. If NVIDIA turns out to be the best solution at the time, we'll happily buy NVIDIA again. But if it turns out to be AMD or something from someone else that can meet all the requirements, it could be something else next time.
Huawei maybe?
Huawei is a bit more complicated for reasons that you might guess. Yeah, and that affects us as well as lots of other people. But we're not beholden to any particular system vendor or solution provider. But I will say HP and NVIDIA have been brilliant. We've had a fantastic experience with them so far. Yeah, they've been really, really good. Dan?
What are your plans about site reliability? You've got a big supercomputer, you want to keep it running, people expect things to work, when things break, you want to fix them, move people's jobs. It's early days yet, I guess, but where are you at with that, and where do you need to go?
Yeah, site reliability. So we're a research facility, so we're not a commercial provider. So we don't need 5 nines, we don't have dual redundant power supplies, we don't have to provide support 24/7, all that sort of stuff. So we're basically a sort of business hours research system, which most people will get to use for free. So that's the flip side of that. People aren't paying us massive amounts of money. We're not Amazon or something like that. If it goes down, it will be inconvenient, but it will come back up as quick as possible. We've got our own support team, but also we pay for a support contract with HPE. So they have people on site, lots of spares on site. We have already had incidents where bits have gone down, or we've had the whole power trip out for the site or something like that. Worst case we had was the Friday evening of the bank holiday weekend. We had an outage, which is, well, that's the worst possible time, because it affects you for the longest possible time. So that's the situation that we're in. So far, though, the system's been incredibly reliable. Our team comes from, we've got people from the Met Office, sorry, Darcy, supercomputer centres around the rest of Europe. People have come to us from Switzerland. Got our first person come to us from one of the big US labs as well. So we got people who really know their stuff. We didn't scrimp on any way that we've done this. We've done it fast, but we've done it to very, very high quality, so that we're not going to worry about, we haven't got lots of problems with things failing or anything like that. We also did lots of testing in advance. So the whole computer was powered up and tested for a month in the factory before it then got shipped to us. Those of you who've done big systems, you tend to still get nodes failing and things like that. I think we've got 1,300 nodes. I think we've had 4 fail during the whole of bring up. So that's way better than we expected, actually. That's gone really, really well. We deliberately picked technology that had already been flushed through by other people. So Switzerland had built a bigger version of Isambard and already got it running before ours arrived. That really helped us. We didn't want to have the very first of something, because that would have been a much bigger issue in terms of bringing it up. So we thought a lot of that through. We've understood what our actual requirements are and objectives, and we're delivering on that. If somebody wanted us to do something that was more kind of 5 nines, we've got people in our team who've done that. We could do it. Maybe parts of Isambard Park 2 will have that. The National Grid tell us if we want 50 megawatts, it will be dual redundant. We can't have it with a single line, which is kind of interesting. And then you could build in the other pieces. Sorry?
You could be a good citizen when you've got such a low grid.
Yeah. Good question.
What about soft errors? I mean, so they typically go undetected, and you get errors in the software execution. Do you have some processes in the background that are continuing to run around to see if any of the modules are
for soft errors? Yeah, we don't do anything sort of specific to us. Big supercomputers have sort of known about that and worried about that for decades now. So there's lots of sort of standard stuff that's built in. All the hardware these days is sort of ECC for double error detect, single error correct, all that sort of stuff. We don't need to do anything much more than that. There are versions of Isambard type supercomputers that are much bigger all over the world, and they have to be stable and reliable. So we then benefit from that by like being a baby brother version of those.
A bit cheeky, but those bigger computers actually do see double error correction errors at the rate of around 1 minute. So it'd be interesting to see what you guys see when you kind of bed it in.
Yeah, we've been up and running for a few weeks, so we'll find out. Some of the big sites are also at altitude, which makes that much worse. You get a lot more cosmic rays the higher up you go. We're kind of at sea level, well, a bit above sea level, but so we've got a lot of atmosphere above us, which helps. But yeah, we'll track that. We're not expecting any particular issue with that.
Are you running the GPUs with ECC on or off? Because you should run the GPUs with it off. Performance reasons.
Oh no, I think at this scale, it's on all the time. Yeah. No, I think the time and effort it would cost you to spot that was the problem it's not worth it. So we just we sacrifice what you need to have it all turned on all the time and just live with it. Yeah.
Last question, and then Simon, I think you will stick around.
Yeah, I'm not rushing off, so as long as someone gives me a drink, I will carry on answering questions.
You mentioned the storage is all flash. We didn't say what it was or what interfaces it was.
Oh yeah.
And secondly, if you're going to reserve capacity, and then you fill the site, but if somebody comes back in 6 months and says, I need another 50 petabytes because we're...
Yeah.
Is there space to do that?
Yeah, all great question about storage. Right, so the bulk, we've got 20 petabytes of basically Cray, Synexion, Cluster Store, I can't remember what the new name is, but basically Lustre, but that's all flash. And we've also got a VAST system, which is where Home lives, and also it will do some other things for us. VAST is really interesting. It's got some really nice sort of enterprise class features around multi-tenancy. And we will have a very diverse range of users, companies, research groups, research councils, and we want to be able to basically carve off bits of the system into their own tenancy that then the rest of the system is completely unaware that it exists, and in fact that tenancy doesn't have to worry about the rest of the system either. And VAST actually has some very nice features to enable that. So that's one of the reasons we got VAST as well as the Lustre system. And all of that's still a bit more to come. We want to support things like trusted research environments, so you can have real NHS data on the system. We've done most of the work to enable that, but there's still a bit more to do, so probably that's months away before we can do that. But I think a lot of the early AI applications in health, they really want to be using that sort of data, so we're a long way down the path to make that possible. And then capacity, in the main modular data center we've already built, that's quite full, but we've got our eye on some more space nearby. This is not Isambard Park, but something else where we'd like to put some longer term storage. Because actually this storage is all for while you're using the computer. So while you've got a project on Isambard, all that storage is basically scratch for you to use. But then when you're finished, your data has to leave and go somewhere else. Or you might say, well, where can it go? And that's a very good question. It turns out the answer is possibly nowhere, or you're begging, borrowing, and stealing. So we propose building something that will be a long-term national AI data facility, which would be nearby. It would be hundreds of petabytes of storage. Some of it would be tape, some of it would be disk, so that you can keep your data long-term, and then high bandwidth from there into Isambard to do your compute. But that's not funded yet. but we're kind of hopeful. We're hearing very positive noises that might get funded in the next few weeks. So if so, that's something we'd build quickly. We'd have it up next summer probably. That's the idea. So anyway, thank you for all the questions. I'm not going to run away. I will.